All right, we are live on Google Hangouts. Google Hangouts, this is called Astronomy Daily Live. And it is 2 hours UTC. And we are here again, gathering together to talk some astronomy and some space and some nerdy things, right? Nerds run the whole thing, right? I mean, whether that is obvious or not, the fact of the matter is that it's the nerds that are doing it all. So yes, we've known all along. So well, welcome everybody. I'm going to test out a Nightbot function called const. Should choose a number between 1 and 88. Let's see if it does it. I'm watching and just sort of passing time here, letting people wander in. So this is just a fun, casual get-together of friends every single day to talk astronomy for a while. Forget about everything else and just think about the universe. Think about practically everything else, right? So yeah, that's one of the cool things about the science of astronomy is that you can literally work with the smallest structures known in the universe, and almost at the same time you can work with the largest structures in the universe. It covers everything, and that's why it appeals to me, because I am just insatiably curious, and I like to understand just out of curiosity's sake, right? I just like to know why and when and who and all those questions. So astronomy and science in general sort of scratches that itch. So all right, well, cool. Well, thanks everybody for coming in, and those of you who are watching this later, hello there. So this live stream is for newbies who are just getting into astronomy and want to find out what it's all about. It's for the amateurs and the advanced amateurs who know their stuff, but like to get together and shoot the breeze. And this is also for pros. To come in and either, shoot the breeze or, talk about what they're working on, whatever it is, right? I'm extremely comfortable with any of those sectors because I have been all of those, and I consider myself all of those. I think in a lot of ways in astronomy, I am just a total noob. Right? I mean, when it comes to like radio astronomy, I don't have a clue. Don't have a clue. But I do know that if I was a radio astronomer, I wouldn't care about the clouds, right? I wouldn't necessarily care even about the rain or the snow. The only thing that you really have to worry about being a radio astronomer is the sun and the moon. So stay away from those, and primarily the sun. You can observe day or night; it doesn't matter. Cloudy, doesn't matter, because all those things are transparent to radio waves. So cool. So yeah, I need to get into that. But yeah, this live stream was established for everyone. Right? This is sort of like a virtual porch where we're all coming together, maybe maybe we bring in our consumables of choice. Cheers. And just shoot the breeze a little bit, talk astronomy, talk science, talk, you know, pretty much whatever. And yeah, so let's do it. So in the panel, once again, there is Bobby. Hey there, Bobby.
Hey, what's up?
It's 84% humidity there. Is that what I saw?
Yeah, if you look at it on the Discord. Hey, you want to know something? That since I'm now getting some subscribers, actually probably might take some of my videos down because they've been mostly been thumbs down and stuff, and maybe try to get some type of good reaction coming in and stuff. Because nobody gives a damn, they'll just keep on doing it on my rant videos.
Probably, but yeah, I think if I don't, Bobby, I don't know if I'm subscribed to your YouTube channel or not. I'm sort of thinking that I probably am not.
Yeah. So say about after the show, I might take some of those videos down and maybe reactivate it some way somehow.
Okay. Well, that sounds cool. That sounds cool. Get the channel a little more active. Cool.
Yeah.
All right. Well, I thought just
I think it's time to really like this song. Take a letter, Maria.
Yeah.
Address it to my life. Send a copy to my lawyer. I gotta start a new life.
There you go. Now's a good time to do that.
That's right. Well, so take a letter, Maria.
Yeah.
Oh man, it's been a while since I heard that song for quite some time. I heard that song on the radio and stuff.
Oh, cool. All right. Well, just a reminder that Mars Insight, the spacecraft that was launched 6 months ago, is going to be landing on Mars on Monday. Monday at 3. They don't give the time in UTC. They give it in Pacific time and Eastern time. It's like, the United States is the only thing on the whole planet that exists, right? It's the only time that really matters. It was really, really funny, just as an aside, to show how much the United States matters, okay? I watched this British music YouTube channel, Sonic Live. I think it's called Sonic Live. Anyway, really, really great, right? But they're like British. They're European, right? But they are talking about Black Friday, right? So I mean, the only reason why it's a Black Friday at all, right, is because the United States has Thanksgiving tomorrow, and then the next day, it's called Black Friday, right? Well, I don't know about the whole world, but the whole world seems to have jumped on to that.
I saw a video one time on Facebook about how chaotic Black Friday can be in America. And how peaceful it can be in Europe.
Yeah, well,
they do wonder, dude. We need God back in our country.
Yeah. Well, anyway, I just thought it was kind of interesting that Europeans are even aware of Black Friday because Thanksgiving to the rest of the world just isn't a day, right? It's just a regular day, right? It's only in the United States.
Just
that it's a
another
big
day in
deal.
paradise.
Yeah, yeah. So this concept of Black Friday um, is a result of the United States having Thanksgiving on a Thursday, right? Um, but the whole world has sort of adopted this Black Friday thing. I mean, it's economic, right? So, but yeah, I just thought that was a little bit interesting. So, all right, well, cool. I think, let's see. Okay, so Mars Insight, that's happening. And sorry, I got off on a complete tangent there. So, uh, I believe that Mars Insight is supposed to be landing at 3 p.m. Eastern Standard Time in the United States, right? Um, so I believe that puts it at 20 hours UTC, if I remember, if I'm doing my math right. So I think it's 20 hours UTC is the approximate landing. I guess they're not going to publish anything exact, right? They probably have a really good idea, right? Probably down to the minute or maybe even the tens of seconds how they want it to happen. Whether it happens that way is, up to things that they have no control over, like the thickness of the atmosphere. So, as this thing is coming in, it's going to be going through, different um, uh, uh, environments in the atmosphere. Hey there, Crooked Ninja 5. Nice to see you in the chat. Cheers. Cheers. Best stuff in the world. Nothing more refreshing than a big tall glass of hydrogen hydroxide. Cheers. All right. Well, cool. So that was one thing, and then I saw that Universe Today, Fraser Cain had published an article, and maybe I can find it here. Let me get it set up, and I'll sort of walk you through the process here. Let's see. Did I? Guess I didn't save the Universe Today thing, so let me try to find that first. Universe Today. Wonder if it'll be easy to find just from the front page. So hang with me a second. I'll try to see if I can get this set up. So here it is. Okay. So I'm up here now. Share the screen. Share the screen. Share the screen. Okay, here we go. Back to infinity we go. So this thing says...
Is that the current sun now?
No, this is just a picture of the sun. They just grabbed whatever stock photo they could probably find. So it says astronomers find one of the sun's sibling stars, born from the same solar nebula billions of years ago. So this is one of the things that we've sort of been looking for quite a while. Is how the theory goes is that our sun, along with a number of other suns, pretty much all formed at the same time, sort of in the same place, but have sort of slowly been spreading out over the last billion or 2 or 3 or 10 years. So to claim that astronomers have found a star that was also formed with our sun, that's quite an extraordinary statement. So I caught that, and it's like, huh, all right, well, you probably need to look into this a little bit. There's this project, I guess it's called the Ombre Project, and that is sort of where I went to.
Crooked Ninja, but I
Yeah,
haven't been looking at the solar report lately, but it's been having some sunspots lately.
yeah, I think it depends on the cycle, and if there are more spots now than what there has been, then it's probably definitely coming out of the low.
That we might be endeavoring to a new solar cycle now, solar cycle 25.
Yeah, we've been low for, I don't know, a year or so.
Okay, so yeah, Crooked Ninja's right. It is spotless. Your solar flux at 69, A at 6, K at 0, and it's spotless.
Ooh. See, so K being 0 is actually really not really very good. We want the K index to be.
No. Your K, when your K is at 0, it's good.
Well,
when your K at 4 is unsettled, but when it goes 5 or higher, that's when you might have some concerns.
Yes, but let me explain. Okay, now to you radio guys, a K of 0 is really, really great, but a K of 0 means that the electrical and magnetic activity in the magnetosphere is very, very low. And what that does is that actually allows more cosmic rays to come through. So you actually don't well, I mean, in terms of cosmic rays, right, which can be pretty nasty to us, a K of 0 is actually not very good. In terms of propagation, oh yeah, that's awesome. But in terms of sort of health, not too good. Not too good. Anyway, so these guys, the Ombre Project, have a paper over on archive.org, which I grabbed. And so it's pretty cool. These guys are over in Europe, right? There's the Portuguese and France and Portugal again and Armenia. So that's pretty cool. And these kinds of abstracts, I don't know. I don't really know if I like these or not. You see how they sort of categorize them. So instead of putting them into a single paragraph, they sort of break it out into pieces. And yeah, maybe I'm just used to the old way, so maybe this is better. I mean, you definitely get a lot more information, but it's also not as short. So let's see, from the about 17,000 stars that were characterized within the Ombre project, we first selected 55 stars whose metallicities are closest to the solar value. So that makes sense. What they're basically saying there is that made of the same stuff. At least the proportions are close. So for these stars, let's see, I'm going to zoom in a little bit here. For these stars, we derive precise chemical abundances of several iron peak, alpha, and neutron capture elements. I don't think I know what that means. Anyway, based on which we selected 12 that have metallicities in that range. So our further selection left us with 4 candidates in terms of age, and let's see, for 2 of the hottest candidates, we derived the carbon isotopic ratios, which are compatible with the solar value. And so they've got 4 good candidates, and this star HD 186302 is the most precisely characterized and most probable candidate. So there we go, HD 186302. Let's follow our noses, because that's what we do here, and see what Sinbad has to say about this particular star, if anything. Doesn't have to say anything. Well, it's a star because Sinbad says it is. So let's see, where is it? Oh, it's in the southern hemisphere. It has a declination of -70. So that's way down there. Way down there. Definitely cannot see that from above the equator. Well, you know, -70 you can actually see above the equator, right? You could be 20 degrees above the equator, and it would just be on your southern horizon at its highest point. Radial velocity, it looks like it's moving towards us at 1 kilometer per second. So that's not really moving at all, right? Parallax, that's actually pretty big. I think 17 milliarc seconds. I think that's pretty big. So they're calling it a G3. I think our sun is a G, is a G5 or a G2? I don't remember. And pretty bright, right? You can't see it naked eye, but it's, you know, pretty bright, pretty bright. And the interesting thing, right, is that from this star, our sun would look about the same. So this is probably your best idea as to what our sun looks like when viewed through a telescope, at least. It's definitely not a great view. You're getting some big diffraction spikes and whatnot. This is the Digital Sky Survey 2. I don't think the Sloan Digital Sky Survey went down there. No. DSS2 red. Okay, I see. It's just a black and white with the red filter. What else do we got here? 2 mass, iris. Yeah, nothing too interesting. Let's see. Oh, here's the blue. So, and this is just sort of combined. Nice little galaxy, right? Almost an edge-on spiral. Yeah, I got some dark stuff in there. Kind of cool. Maybe a spiral. It's kind of hard to tell. But there it is. It's just a pretty boring old-looking star. Let's see. Of course, it's got a bunch of different names. Got some references. Let's take a look at these. So 56.45 parsecs. So here, watch this. I'm going to go over to the chat. I'm going to make our Nightbot earn its keep. 3.26 times. That's because there's 3.26 light years in a parsec. And Nightbot will compute the number of light years for us right before our eyes. Wow, look at that. 184.027 light years. So actually, that's pretty far, right? I mean, if they're saying that this thing is a sibling to the sun, that at some point they were, you know, yeah, I don't know, 184 light years. Maybe that isn't so big. Or, yeah. How big is like the Orion Nebula? Isn't that close to? Oh, that's not that big. How big is the Orion Nebula? Orion Nebula is its shell size 30 to 40 light years. Okay, so the Orion Nebula is 30 to 40 light years, and they're saying that this thing is 184 light years away. So, I don't know. We'd have to look at the paper, you know, to see how they actually came to that conclusion. We can sort of look a little bit. It's got pretty high proper motion, pretty high. About the same temperature as the sun, at least the photosphere of the sun. Cool. Well, let's see what this has to say here. So on the incidence of WISE infrared excess among solar, analog, twin, and sibling stars. Pastel catalog. Oxygen abundances. Photometry. So in 2014, they were talking about it being a solar sibling candidate. So let's see if they actually mention that star. Ooh. Let's see, what is it? 186302. See, now this is a different one. So, yeah, we can probably get a list of those four. Let's see, probably down. Wow, this is a large paper, 21 pages. Holy moly. All right, well, we're just gonna, I think I just want to, if it's all right, I'm just gonna see if I can just find a list. Because, you know, this of course describes their methodology and all of that, and that's cool. Okay, so the 4 best fit sibling candidates. There they are. So let's see, are there some tables? Maybe there's some tables. Appendix A tables. Ooh. Here we go. So stellar parameters of the full sample stars. Okay, so these are all the stars that they sampled. And there's some plots. Okay, we're getting to it, I hope. Figures. Okay, more plots showing various values there. Effective temperatures. Come on. Oh, what do we got here? Abundance ratios. Come on, I want to see this list. Oh, there's no list. Oh, man. Ah, this is bad. Okay. So let's go back to, you know, expectations are just destroyed. Let's go back to that. Here's the big list. Lots of references. That's nice. Oh, where are those? There they are. Okay, so 186302, HD 126829. Was that one of them? I don't think so. No. Okay, so yeah, back in 2014, they were aiming at, well, somebody else was aiming at something else. So, that's too bad. Several methods. Chemical abundances. Parcus stars. Pastel catalog of stellar parameters. Photometry. So, okay, well, dang. It's kind of interesting, right? That hasn't really been well studied. 186302, right? That's what we're after here. 186302, yeah. 186302, yeah. Huh. Not quite sure why they pulled that one out. I mean, the error bars are the smallest. So maybe that's why they're just the most sure about that one. That would make sense, I guess. Pretty cool. Looks like that's a sibling of the sun there. So pretty cool. It'd be probably pretty interesting, but pretty mind-bending to go through their logic. Yeah, I mean, these various diagrams. Yeah, I don't even know what that is. Some kind of velocity space plot, but hard to know. Let's see, is there anything else? I'm just sort of identifying 186302 here. So, okay. Well, whatever that means. Looking at the age, that makes sense. It's got to be the right age. Abundance ratio, so this is iron to hydrogen. Let's see. Surface gravities and temperatures. Of course, we're reading this backwards. That's all right.
Get up here.
It'll make as much sense going backwards as it is forwards anyway. So, yeah, wow, that's quite a scatter. You know, they try to do a fit. You know, I mean, you can fit anything, right? You know, computers don't care. They'll fit a line to anything. So, you know, there is a trend here, right? If you sort of take the black dots, right? There's a structure here. They're not randomly situated, but you know, if they're trying to fit a straight line to that, that is the best fit, but it's a terrible fit. So yeah, whatever they're sort of looking at here, they they probably need to improve their models a little bit. They're not very close to what they should be. All right, well, cool. Yeah, pretty amazing methodology too. So yeah, very cool. Very cool. All right, well, let's see. I think, let's see. Well, cheers. I think that we should probably do that we should do an object of the day. I really do.
Yeah.
I think we should.
Yeah, I wasn't paying a little bit too much on the. I was deleting some of the videos that's got mostly the thumbs down, but they're not going to be up unless there are some comments. But the ones that are even or mostly thumbs up, those are the ones that I kept.
Cool. Excelente. All right. Well, let's do an object of the day then. I've been sort of wanting to do that, and I think what we can do once again, I have a Nightbot function that will choose for us the either the Messier object or the NGC object that we want to.
I've seen it in the constellation as well.
Yeah, I've got the constellation in there too now. So yeah, I've got all three. But let's do an NGC. All right. So here we go. May I
do the honors, please, Cosmic?
What's that?
May I do the honors?
Please.
Okay. Try to get the keyboard up. There it goes.
So we're going to choose an NGC object, a random NGC object. So there's 7,840 of these. And so Nightbot is going to choose a number between 1 and 7,840. And there it is, 5947. Thank you, Bobby. Yeah, I think that's kind of cool. So, all right, so 5947. Let's go back over to Simbad because, you know, Simbad is just a really, really great source for any astronomical object. It doesn't have to be a galaxy, right? It doesn't have to be, I mean, it can be any astronomical object. And usually you can search for it by a common name, right? Even though, you know, all of these objects have multiple names, right? Some of them have, you know, 10 or 20 or 30 names, right? But there might be a more common name, like, you know, Sirius or Canopus or Betelgeuse, or, you know, the Dumbbell Nebula. So you can type that into here too. So all right, let's grab. I forgot what it was already. Let's see if we can grab that whole thing. NGC 5947. Now it's probably a galaxy. Probably a galaxy. The NGC numbers are ordered by right ascension. So the low NGC numbers are going to have a right ascension around 0 hours, and the high NGC numbers, around 7,000, 7,500, are going to have a right ascension around 22 or 23 hours, and then of course it wraps around at 24 and goes back to 0. So 5947 divided by 7,840 is 0.75. So if I multiply that by 24, it should have a right ascension of around 18 hours, which is kind of unusual for it to be a galaxy, right? Because that's right. That's right where the Milky Way is in terms of right ascension. So this may not be a galaxy, but let's find out. You ready? So we could only speculate so much. We need to just dive into it here. So here we go. Ready? Bam. Uh-oh. No known catalog could be found. Oh, I don't believe it. NGC 5947. Let's do this. That's ridiculous. There we go.
That's a lot better. I don't know
Yeah.
why. I guess it's case sensitive.
I have no idea. Yeah. But it is a galaxy. And wow, look at the right ascension. It's at 15. So wow, the NGC catalog in this case is a little bit off, right? It's a little bit off. It's a few hours off. So yeah, we're still sort of in galaxy land at this right ascension, but it is a northern hemisphere object, right? So it's pretty high up in the north. So that's pretty cool. It looks like it's a barred spiral, a spiral, I guess type B or type C, which is characterized by these big arms, these big spread out arms. And yeah, that's exactly what we've got here. This is a nice looking galaxy. Wow. It's also got a bar going right through it too. You see that? I'm going to zoom out a little bit. Do you see this bar going all the way across? And then you get the spiral arms. So kind of cool. That's kind of a nice little galaxy. You see where the color here is more of a yellowish or maybe a brownish, and if you use your wild imagination, sort of reddish, except where all these blue spots are. Those are most likely, like active star forming regions where it's really, really hot, really, really blue. So very cool. Let's zoom out a little bit. I wonder if HST ever took a look at that galaxy. That's a pretty one. Oh, there's some galaxies around. Oh, come on, there you go. Yeah, that's sort of an oddball looking galaxy there. Look at that. Maybe that's just a background galaxy. That's hard to tell. I don't know what galaxy that is, but yeah, that's really odd looking. Here's another weird thing over here. The center of this isn't. Yeah, wow, that's kind of a weird looking galaxy. I wonder if we can find out what that is. How can we find out what that is? Shoot. We can look up the RA and DEC, but that's not going to help us very much. 1529 and plus 42. The only thing I could think is to look it up. No, it's not going to be on my charts. How are we going to find this guy? He's sort of an oddball. Ooh, here's a nice barred spiral up here. Wow, look at that. Wow. That's pretty spectacular too. We're getting extra bonus galaxies here. Yeah, there's a ton of galaxies around. Oh, what was over there? Oh, just a glint. Looks like just a little. I mean, it's hard to know if it's an actual group or not, but it looks like it's just sort of a little group. And, I got to say, right, they're all sort of the same size, more or less. You know, this looks smaller because it's edge on, but if you go from here to here, that's as wide as that. In fact, it's maybe even a little bigger, right? And then these guys over here. So, you know, this might be a part of a cluster. Hard to know. Hard to know for sure. But pretty nice. Got some pretty nice galaxies in this area for sure. But there's our guy. Cool. So 5974. Let's see if let's see what's really weird. That isn't coming up. All we have I was have to go this way, which makes me not happy. Oh, did I go? Nope, I went to the wrong. There it is. That's not it.
Like I said, I should have. You should have like bookmarked it.
I should have. There we go. Okay, look, I'm going to bookmark it. I'll just put it right there for now. Okay. All right, so what is this? What is this bad boy? 5947.
What's up, Andy?
Hey there, Andy. Now the chances of HST actually observing this is very low, so don't count on it. But it's always nice to get a little bit of a surprise here, a little bit of tension before I hit that search button. Okay, here we go. Bam. Nope, nothing. That's a bummer.
Like they do in anime shows.
Yeah. Let's see. They're
like in anime shows. Whenever they do that feint, they usually have their legs up.
You know, there's that NOAO site. That's the archive of all the data that's ever been collected at Kitt Peak. I'm trying to remember the name of it though, because I don't think I saved it. Shoot, I'm not remembering that one. Something like, well, let's see. Let's go over to NOAO. National Optical Astronomy Observatories. And let's see, where can we look? Mission images turned. Yeah, somewhere here. I'll bet we could find a link to it. But we may not easily find it. Image gallery. The data center. Okay, this is getting us closer. It's getting us closer. All right, here we go. Telescope survey programs. Science data archive. Here we go. Is that what we're looking for? Oh. Huh. For general search for NOAO data, all users. I don't recognize this interface. Okay, this isn't exactly what I was expecting, but hey, you know, let's since we're here, let's do it. 5947. Resolve. Target resolver failed. Let's try. Oh, you dummy! What is it using for a target resolver? That's a no-brainer, dude. All right, I'll do it this way. We have the power, and like I keep saying over and over and over again, you gotta be patient and you have to be tenacious. So here we go. Paste that in there. Oh, I don't know if that's the format that they want, but that's what they're going to get, unless they tell me otherwise. You see, I'm not getting the fraction of the arc second there. It doesn't matter. Okay, so let's let's do a search box size. Let's do like 30 arc minutes. That's the size of the full moon, so that's pretty big. So I don't know.
Search button like on top.
Yeah, I see that. Might as well grab these. Sky subtracted. I don't know if it grabs all this. I'm not exactly sure. Do you have to select? Oh yeah, you gotta. Should we just select them all? Okay. We'll select them all here. That's a little excessive, but you know we're having fun. And, you know, look, if this thing can't handle this, then they got to talk to their software people. All right, here we go. Ah, decimal format. Okay. So it wants it in decimal format. All right, well, I can do that. My handy-dandy calculator that I just grabbed off my desk can convert 15, 30, 36 to decimal, 15.51. I assume that they want it in right ascension in hours and the declination in degrees. 42, 43, 1. It's 42.7 something. My calculator is having a problem with one of the digits. Actually, you know, I can multiply that by 100 and get what that is. One more.
It's better if you use the calculator on the computer.
Yeah, that's probably true. But doing these conversions isn't so easy. So, all right, here we go. Let's see if that'll. Processing my query. Please wait. I asked it for a lot. I don't know if that was the wise thing to do or not. We might just sort of be frozen.
Jeopardy music.
Well, while that's going, let's see, what can we do here? We can, well, there's a bunch of papers on it. That's kind of nice. Let's see if there's anything sort of relevant here. This thing, Sinbad is calling it
welcome, Daniel Brownie, to the chat.
Hey there, Daniel. So this is an AGN. So it has an active galactic nucleus. That's kind of cool. Oh, so Khalifa. all these papers have to do with Khalifa, the Khalifa survey. Molecular and ionized gas kinematics in nearby galaxies. Khalifa, wow. There's a lot of Khalifa. It just goes on and on. Here we go. So the structure of solar radio noise storms. Now, what does that have to do with this NGC object? I don't know. Galaxy groups. Updated ultraviolet catalog. More Khalifa. These guys just aren't letting go. 2-mass redshift survey. Description and data release. The EFIGI catalog of 4,458 nearby galaxies with detailed morphology. Let's see if capacity problems. Okay. All right. Yeah, that is totally my fault. I should have oh man. Do we need to re-enter all this? Oh, that's bad. So okay, let's not oh shoot. Let me go back and get the RAN deck really quick. Sorry. We'll remember that one. Okay, so 15, 30, 30, 36 is 15.51. I'll be a little bit more reasonable with these. What was it, 26? What was it? 42. Oh man, I'm totally off. 42.7, right? Wasn't that? 7. Okay, so let's just do the mosaic imager on the 4 meter and on the WIN. Can we do this? And on CTIO, we'll just do. Oh, we've got that one and that one. Now CTIO is in the southern hemisphere, so I'm going to skip CTIO. Wow, I don't remember where SOAR is. Well, let's take a look. Okay, maybe that's a little bit more reasonable. And we'll still do, I don't know. Let's do 15. We'll narrow it down a little bit. I think we just asked it for too much. Just always a possibility.
A big fat bobo.
Uh-oh. Results set empty. Your query did not return any data. Please refine your query criteria. Okay. So it didn't find any with those imagers. So, well, that's kind of a bummer. This actually wasn't what I was looking for. There was another interface to some other data, but yeah, I don't know where any of that is. Oh well. Maybe it's the data. Is it the data lab? Oh, this is it. This is it. That's what I was looking for. We're doing this? I'm not remembering now. Yeah, I think. Yeah. Okay, so 1551 and 42.7. We'll do one degree. Zero images found. Well, shoot, we're not doing too well here. So, all right, well, let's go back to where we were. Past all the Khalifa or Khalifa. We were looking for this guy. 4,458 nearby galaxies with detailed morphology. So here, let's go this way. And we'll grab it over on Archive, or wherever it wants to grab it from. Internet seems a little slow tonight. Or it's a big paper. 27 pages. Hey. All right. Well, let's... What was it? 59? 47? Let's go back to the chat.
WWE shenanigans.
Look at all those shenanigans.
Why the heck would you think about that, Daniel?
So 5947. 5947 is what we're after. So let's just look for it. 5, 9, 7. It's not there. This happens a lot with these papers. Oh, okay. They're listing it by PGC number. PGC. Oh, what did I do?
Why you want to print it?
I don't know. Trying to get it here. I was looking to see that. Can I see those labels? No, it's not. How are these ordered? Is there any order to these? These are actually pretty amazing looking galaxies. I don't know if I've ever seen this.
Daniel, Bruce, we're gonna have another panelist real soon. He'll join on Saturday. And that'll be Daniel.
Oh, cool. Cool. Just send me an email, cosmiclettuce@gmail.com, and I'll get you hooked up. All right, so let's look for the PGC number of this bad boy. Now, unfortunately, I think we have... No, I guess... Oh, no, here it is. So we have the ability to see if it has a PGC number. Uh-oh. Ooh, I don't see a PGC number here. Uh-oh. Well...
That was skunk.
Yeah. So... Either... Well, no... I would think that Sinbad would list something like that. What do these numbers look like? So 0055517. Oh, they're not really in any order either. But they're like 7-digit numbers. PGC 7-digit numbers. Are there any 7-digit numbers here? Not really. Yeah. Oh, well, that's kind of a bummer. That, I mean, I guess that sort of
Now,
means
when are
that.
you doing another scope away? Like, go with your scope and stuff.
What's that?
Now, when are you going to do like another live stream with your telescope?
Oh, I don't know. I don't know. I mean, there has to be something to look at. So, there was a great opportunity that doesn't happen very often. This last summer with all the visible planets up in the same sky, and so yeah, I mean, there's something to look at, but now, I mean, really, Mars is sort of over there, and then there's the moon, and it's like, yeah, I mean, I think the moon is really, really great, but how many times can you look at the moon? I don't know. So yeah, I don't know if that's going to be happening anytime soon or not. If I yeah, I might. I could always do like an observing run, collecting data, but there's not a lot of action there, right? Because I mean, I'm going to sit on the same object, for 2 or 3 hours, and that's all there is. So yeah, I don't think that's extremely interesting. So yeah. Anyway, it sort of looks like this object is not in this list of galaxies, but I think these galaxies look fabulous. And now I kind of, okay, so it's just a catalog. Um, let's see what this EF. Oh, let's zoom out a little bit. Let's see what this EF. The EFIGI catalog, a catalog of 4,458 galaxies with digital images and detailed morphological information. The aim of EFIGI, which, okay, so here it is. It's a French acronym, which I'm not even going to try, is to build automatic morphometry measurement and classification systems operating on resolved galaxy images. So that's kind of cool. They're trying to automate identifying galaxy types. So that's pretty cool. So let's take a closer look there. I like galaxies. I think of all the objects in the sky, I like galaxies the most. I like them all, but this I definitely like the most. Wow, he's right next to a bright star. Look at that. And here's two. Well, yeah, there's a lot of those. Wow, he's right next to a bright star too. But look, they got it probably right. Kind of cool. Some elliptical galaxies here. We're calling this one an SO. I guess, yeah, there's a little darkening right there. You see that?
Now, that focus that you had, is it still working or what?
The what?
That focuser for your telescope, is it still working?
Oh, yeah. As far as I know. Fantastic galaxies. Such a diverse, I mean, each of them are individuals, right? It's sort of hard to characterize them or put them into groups. But, yeah, we try. That's kind of a weird looking one. Pretty cool, though. I like this catalog. This is nice. A lot of the spirals seem to be face on. Well, okay, well, I just contradicted myself there, but it seems like a lot of the spirals are almost face on. Here's an edge on. Yeah, well, maybe not. Okay, see, it's making me a liar now. There's a bunch of edge ons here. So, all right. Huh. Wonder what's going on with that guy.
So Daniel, you're Digital AU on Discord? The one that did that rubber and stuff?
Okay, if that's Daniel, then cool. Yeah, all right. Now we've got a reference. Wow, look at that one. That's.
But I guess to take that as a yes, huh?
Let me see. I gotta keep track of the trouble here. Okay, cool.
Okay.
Yep,
yeah.
Daniel, since you mentioned that, there are actually some 3D things that I would like to do in terms of my artwork. I mean, you're pretty far away, but yeah, I'd like to turn some of my artwork into three-dimensional objects, and a 3D printer could very, very easily do that. So maybe, yeah, if you want, get a hold of me, email cosmiclettuce@gmail.com, and yeah, maybe you can just sort of point me in the right kind of direction. But yeah, let's talk about some possibilities there, because yeah, I've got an interest in going that way, and just really haven't been sort of presented with the opportunity. But this sort of sounds like an opportunity, so hey, I'm going to grab it. We'll finish looking up at these galaxies. These are really fabulous photographs. Now, most assuredly, these are not the best photographs that can be done, because this is science data, right? I mean, they're trying to do science with this stuff. They're not necessarily trying to make the prettiest picture, and oftentimes those two things clash. So, but I gotta say, these are some pretty nice shots, right? Pretty nice, pretty cool. All right, well, I'm gonna get out of here. It looks like it's past time. It's 3:14 UTC. So yeah, I think it's about time to get out. Daniel, if you want to get a hold of me, please do. Yeah, because I would need to send you a file of some sort, and I'm not quite sure what kind of format you need there. So yeah, we'll chat about that offline. So all right, everybody. Well, thanks for coming in again. It's been great. It's always nice to do an object of the day, just sort of a random, who knows what. This one was pretty good. I don't think we really found any papers about it, though. So don't know how well studied it is, but it's probably neglected like all the other trillions of galaxies out there. So what can you do? All right, well, take care, everybody. I will see you in a little less than 23 hours from now. Just one little spin around. It's nice and smooth, though, so no worries. You're not going to fly off or anything. You can actually calculate the centrifugal force pushing us outward versus the gravitational force pulling us in. And it's amazing. You know, you would think that you know, this body on the end of a string that is, what, 3,000 miles long would be a huge, huge, huge force. And it is. It is. But it is dwarfed by the gravitational force. I forget exactly, but it's some insane ratio. Just really, really, really big. Thousands and thousands and thousands. So, all right, you guys. So you're not going to fly off. Just hold on, keep going, and I will see you later. Bye.